Welcome back. This series of videos is intended to help you prepare for your final exam in Math 109. So I've cheated. I've already written out solutions. And what we're going to do is I'll run a series of videos here whereby we'll use the visualizer and we'll take a look at solutions to problems. Hopefully, we've already printed out problems from the review stack. And I'm going to go ahead and hopefully this visualizer will kick up. And if we're having a good day, on the screen, you can see the beginning work from chapter 1. For us, that was unit number 1. So again, I've already cheated. I've got the problems laying over here. What you can see on the visualizer are solutions to those problems. We'll talk about them as we go. Problem number 1, 6 people playing a round-robin chess tournament. Remember, you're one of those 6 people, so you'll play 5 others. That's why that 5 is there. All right, the next person will play 4 others in addition to having played you possibly. The next person will play 3, the next person will play 2, and the last person will play 1. So the answer to problem number 1 is the sum of 5 plus 4 plus 3 plus 2 plus 1. There would in fact have been 15 games played. Problem 2, Fred and Barney. Now, we're finding the least common multiple here, so I busted out the old ladder method that we looked at in Unit 5, and my values are 14 and 10, so I realized the 2 goes in, and that's how the 7 and the 5 got there. To find the least common multiple, we'll multiply the 2 times the 7 times the 5, and we'll find that both Fred and Barney will visit the quarry on day 70. All right, problem 3, a lot going on. You got friends, and they've decided to split the bill evenly. So on the left side, you see the total costs, 5, 22.50, 20, 10.50, and 22. $80 being shared equally among 5 folks means everybody's going to pay $16. So their next challenge is to figure out who's overpaid and who's underpaid. So we see that Alan, he's spent a paltry $5. So he owes 11 to get up to 16. 5 plus 11 more to be 16. Skip has spent $22.50. So somebody's got to give him money. He's overspent. He needs to get $6.50. Stella spent $20, so somebody's got to give her 4. She's overspent by 4. Susie spent $10.50, so she needs she owes $5.50 to get to 16. And the last person is Sparky. He spent $22, so he's 6 over, so somebody's going to have to give him $6. Now, the thing I should point out on these possible solution methods, this is certainly not the only solution. It is a possible solution. So I decided that Susie would give some money to Skip, namely $5.50, and that squares Susie, and it squares Skip if Alan gives Skip $1. Okay, so remember, Alan owed 11, so he's paid 1 to Skip, so he still owes more money. So he's going to give Stella the 4 that she needs, and he's also going to give Sparky the 6 that he needs, and that levels everybody at $16. All right, problem 4 is the elevator problem. Everybody loves elevator problems. Okay, so I started this at the middle floor, and we moved up 6 floors. That took us to middle plus 6. Then we moved down 8 floors. That took us to middle minus 2. And then we decided to move back up. Looks like 11 floors, and that took us to middle plus 9. And then we realized at that instant that the top floor is 6 floors above that. So the top floor then is middle plus 15. That means there are 15 floors above the middle. That means there better be 15 floors below the middle. Just don't forget to also include the 1 for the middle floor, and the building would have, you guessed it, 31 floors. So there's our first set of solutions coming out of chapter 1. Let's switch the answers. Here we go to another page. All right, visualizer working hard. Okay, continuing work in chapter 1. All right. Susie had all her scores. There were 12, and found her average to be 74. Teacher says, go ahead, drop your lowest score. Susie's lowest score was pretty sad. It was a 30. Question says, what will Susie's new average be? So you find out how many points she accumulated by taking 12 times the 74, which is her previous average. That's 880 points. Take away the 30. All right, so now that's 858 points. But remember, now you're only averaging 11 scores and not 12. So take the 858 and divide by 11, and you find that Susie's new average is 78. So she went up from 74 to 78. Time for some sequences. We're supposed to decide what are the next three terms and decide whether the sequence is arithmetic, geometric, or neither. For 6A, looks like the next three terms are 15, 21, and 28. In each case, you're adding one more than you added the previous time. So we added 5 to the 10, then we added 6 to the 15, and we added 7 to the 21. That is not arithmetic. It's only arithmetic if the number that's being added stays constant. It's not staying constant this time. So that's neither. All right, part B, we went from 50 to 40 to 30 to 10. Looks like maybe then 10 and 0 and negative 10. That is arithmetic. You're taking away 10 each time. Last one, C. Looks like the numbers are being diminished by half each time. So the three terms we need to find are then be half of 800, half of 400, and half of 200. So I make them 400, 200, and 100. That is geometric if you are multiplying by a fixed constant or dividing by a fixed constant. That's the definition for geometric. Number 7, we're writing terms for sequences. 7A is a recursive form. First term is given at -4. The recursive rule says we'll find subsequent terms by taking the term that we have and adding 6. So we'll take the first term, which is -4. We'll add 6, and that will create our second term, which is 2. Then we'll take our 2, and again, we'll add 6, because that's the recursive rule. That builds the third term. That's how the 8 got there. Now we'll use the 8 to build the next term, and you guessed it, we'll be adding 6. And last but not least, we'll take that 14 and we'll add 6 one more time, and that will create our fifth term. So the first 5 terms are -4, 2, 8, 14, and 20. Part B is an nth term, and all you have to do is put in 1 to get the first term, 2 to get the second term, 3 to get the third term, and so on. So if you put 1 in for n, 3 times 1 plus 6 is 9. If you put 2 in for n, 3 times 2 plus 6 is 12. Putting in 3 for n, 3 times 3 is 9, plus 6 is 15. So you want the fourth term? Sure, let's put 4 in for n. 3 times 4 plus 6, 18. Last but not least, fifth term, 3 times 5 plus 6, 21. So our first 5 terms would be 9, 11, 15, 18, and 21. All right, it's time to sit some people at a table. And we have 16 square tables, and each side can only sit one person. So the important thing to realize here is if you've got these tables in a big string, a big line, 2 of the tables will be able to seat 3 people, the ones on the ends. So you'll be able to sit 3 people at the 2 tables on the ends. All the other tables will only be able to seat 2 people. So if you in fact have 16 of those tables, 2 of them will be able to handle 3 people. 14 of them will only be able to handle 2 people. So you will be able to have 6 plus 28, or you'll be able to seat 34 people. Packer shirt and Packers tie sell together for $39.50. Shirt costs $11.50 more than the tie. So I let X represent the cost of the tie. That makes X plus $11.50 represent the cost of the shirt. You know that if you add those two together, you get the total bill of $39.50. So 2x plus 1150 is 3950. Take away the 1150. 2x is 24. Divide by 2 and x is 14. So the tie comes in at $14 and the shirt comes in at $25.50. And that takes care of the solution for number 10. And that, my friends, is the end of the problems from chapter 1. So I'll see you soon on video 2 as we continue our review for the final exam. See you then.